All right, so if this session is being recorded, yes. I guess only our introductory part is not, when we're introducing ourselves, it's not going to be included in the recording. But then, yeah, like I mentioned, in this course, we are going to understand the basic concepts of AI and ML, everything that's involved in AI and ML. We're going to learn these foundational techniques that's involved in AI and ML, like supervised and unsupervised learning, because you can, in a way, categorize AI or machine learning into supervised and unsupervised learning. Everything we do, either you are training the machine learning models or the AI with something that you know, or you are training it to learn from something that you don't even know. And now we are also going to explore the tools and then the frameworks that's involved in building these AI and ML models. All right. And then as at this point where we are going to be deeply dependent or yeah, very dependent on the Python programming. And then once we have understood, we have learned, we have gone deep into the tools, and then now you have the tools, you have the know-how. So what do you go? You go out and build. You go out and you apply. In this field, um, nothing beats learning than applying. Okay, nothing trumps you building up skills in this domain than applying. So then we are going to make sure that at every, I think after every 1 month or after every section of the course that we do, we are going to build a program, or we are going to build an application, or yes, we are just going to apply it on the project. So since we are a class or we are students, we just want to lay down some foundational rules to help us be able to do this or achieve our objectives at the end of the program. First of all, our meeting days on Wednesdays are 7 p.m. And then I think there's a Saturday date which is going to be 6 p.m. I think it's going to be communicated on the page. What we want from you is that you are going to be present and engaged at every time. All right. You are going to be present when we come inside. We are all going to mute our microphones until, like I did earlier, ask all of us to unmute and then just share something, or I ask a question and then you do. Now, in this, what we expect of you as well is to also participate actively, ask questions, like ask questions, try and ask questions. If you don't understand anything, try as much as possible to ask questions. Sometimes I'll be teaching something or I'll be explaining something and then explain it in explain it such that uh, uh, I think you get it, but then you probably don't get it. So then you can just ask questions so that I understand how much the students are understanding. Also, we'd like that you respect each and every one that joins on the call, especially when they are asking questions and you think maybe the question that they are asking is not something that they should ask, and so you make a cheeky remark or something to discourage them. Would gently or respectfully advise against that. Now, you don't have to necessarily turn on your camera, but it's great if you can see ourselves. And then, as and when, we will take breaks when needed so that class can just rejuvenate and then we continue. And most importantly, stay curious. When we do our sessions here, it's very important that when we put any books inside or we add any resources that we should read, it's very important that you do so and then you read and try to find out more, because as much as we are here to teach you and guide you, we cannot impart with you every knowledge that is in this domain. So you also have to do your due diligence and go out there and go and study. Now, this course is a data science course, okay, but you can't do data science without ML and artificial intelligence. So you see that we are talking about ML and AI. We are talking about ML and AI, because once you have done data science, you have in a way done ML and AI with just a few things remaining. Uh, Now, the discussion, it says here, the AI is basically like a branch of science, all right? That is assisting machines to find solutions to complex problems in a more human-like fashion. So you are basically training machines, or you are building machines to be able to behave like humans, solve complex problems like and even better than humans in certain scenarios. So we try and impart them with the intelligence of human in so that they can mimic human intelligence. Now, what are the components that are involved in AI learning? AI, there's no AI without a learning process. There's no AI without a learning process. You'll be hearing training the AI. It's basically the AI learning. It's learning from text, it's learning from audio, it's learning from resources that human fits it, and then based on a set of rules and everything, they teach it to be able to reach a particular sort of reasoning such that it's going to be able to solve problems. So they add logic into it. Now, back then, how they were building AI was that they were using a lot of logic. If this, then that, if this, then that, if this, then that, if this, then that. But you get to a point, it becomes too much. You cannot technically cover every scenario. All right. So then, instead of using if to do the rules, now they use more mathematical approach for the rules so that it can learn from the data and then develop its own reasoning methodology to solve problems. Now there are other aspects to the AI. That's perception. That's when it's able to interpret sensory data like visual data, audio data, and all those things. Because in a way, if you want AI to interact with the environment, it has to transcend beyond you just providing text to it. It's supposed to be able to perceive its environment like robots. It's supposed to be able to see, be able to hear, and all those things. And even now, they are adding artificial skins to robots, which is using AI, so that it can also include all those perception and stuff. And then in all that I've mentioned, I think uh, most importantly, AI is supposed to be able to understand uh, humans. Now, the history of AI started a long time ago, but when they started being more predominant was when a man called Alan Turing came out and then started laying the foundation for machine intelligence. Basically, what he did was he created a machine, he created a program, or he even created a test, all right, that should be able to differentiate or indicate the performance of an AI, such that if you put the machine and then the human being behind a counter and you are interacting with it, if you are unable to determine the difference between the machine and then the human, then if you are unable to, yes, determine the difference between the machine and then the AI, then you can see that yes, this AI is very good, right? So then you have periods when AI started developing. Now, one thing that's important to know is this AI winters. What's an AI winter? Now, there were periods where um uh so AI winters were periods when please give me a moment. So AI winters were periods where there was less funding for uh, AI research or AI work. There were less funding. There were less interest. Investors were not interested. Why was this? Because there wasn't a lot of, let me say, results from all the work that was being done from the beginning. From Alan Turing, they came out like it looked like it was something that was promising. I mean, machines are going to be able to do all these things for us. But then 10 years, 20 years passed, and then we are not seeing any results. They were not seeing any results because at that time there wasn't enough computational power. At that time there wasn't these all these programming languages that were supposed to be helpful or that are helpful in this time and age, right? So then investors started pulling back. I think there were two AI winters before when uh, modern machine learning formulas and methodologies and all those things started coming inside. A lot of people started picking it up. Now, machines were able to help. build these models and all those things. And then the boom of modern AI came as well. So now, what are the subfields? We've seen the concepts that are involved in AI. Now, what are the subfields of AI? Like I mentioned, we are talking about data science, but then the data science goes with machine learning and AI. So then, at least we look at it from the top. Then we come back to data science that we are going to be talking about. Now, the subfields of AI. AI encompasses basically all these things. Machine learning, where algorithms learn from data. Now, what are algorithms? They are basically a set of rules or logic that a machine will follow, a computer will follow to execute a program. And then you have natural language processing where computer is able to process human readable language, or computer is able to also understand human language. And then you have computer vision, like I mentioned earlier, where uh, computer is able to understand human visual inputs. And then you have robotics, which com combines a lot of the other subfields of AI, like computer vision, natural language processing, machine learning, and other aspects of science like physics, mechatronics, automation, and all those things to build that. And then you have expert systems that are so expert systems are basically tuned AI that are there to be able to be good at something very specific, right? So you can take like an AI that is built to provide legal advice. Okay, it's an expert system because it's built mainly to be able to be an expert at legal stuff or health stuff or anything. Now, um, now, it's important for us to understand all these things because when you get to trying to solve a problem, let's say you are trying to solve a problem in health and you have data there. First of all, you have to understand in what form your data is coming. You take the health department like this. Sometimes data comes in text, that's patient's information. Sometimes data comes in visual, so in the form of visual stuff. So that's like stuff like X-ray and then some other these scans and stuff, right? So then when you know the form that your data is coming in, they know the form in which you are going to be solving your problem in, or in which domain of AI that your problem is going to be inside, so that you can focus um your uh, efforts or resources there. Now, when we come to the field of machine learning, that's data science, or that we use in data science, there are three components. There's supervised learning, where so so we have something that we call label data. So take let's say we want we want to be able to detect or predict fraudulent transactions or Momo transactions. All right. The label data is going to be a list of transactions that we have indicated that okay, um this transaction is a fraudulent transaction. This transaction was not a fraudulent transaction. This transaction is a fraudulent transaction. So that information that we have added to the data to indicate what we want to be able to predict so that the machine will learn from that. That's the label data. So then now we are building the machine learning model in a supervised environment. We only want it to look at these things that we want. There are instances where you don't you don't know that label data. You cannot do that label data. Even for this fraudulent uh, scenario like this, sometimes you don't even know what sort of things leads to the fraudulent activity. Maybe yes, at the end you know that okay, this transaction was fraudulent, but there are a few other things that are done prior to the transaction that is indicating like a fraudulent transaction, and you don't know those things. So then you can use algorithms like clustering and all those things. That helps you to separate all these transactions and all those things and be able to uh, basically predict or in a way detect fraud earlier. And that's an unsupervised form of learning where you don't know what you are looking for, but you just know that there are some distinctions in the data, and then you train the model to be able to learn from that distinction. And there are methodologies or models that are there that can do that. And then lastly, we have reinforcement learning. Now, in most machine learning solutions that you are going to be doing, you are not going to be using reinforcement learning a lot. But then in something like robots and all those things, some things are there you cannot just train it. It's not just one. It has to learn from itself. Okay, it has to learn from itself. It has to learn by doing, and then by doing, it gets better at doing. And then the way it gets better at doing is that at doing a particular task is that there are human beings that are telling it that okay, this thing that you are doing, okay, the human beings that rewards it that okay, this thing that you are doing, this is the right way to do it. So continue doing it like this. So you are rewarding the models for good acts or good behaviors, and you penalize the model is the term they use for when it's not doing the task well. So take for instance, there is an AWS let me see, I don't know if I'll say game or something called AWS Deep Racer, where you have to train a racing car. It's an autonomous car. You have to train a racing car to be able to like navigate a path. Okay, so when the racing car starts, it's the racing car is supposed to be able to detect the path and navigate on its own. But when it starts, it cannot really do anything on its own. So you have to be when the racing car is moving, you have to be telling it that okay, this action that you did was good. So follow this action. You'll be able to continue the path. Then if it's veering off from the path, then you go and change some values to tell it that okay, this action that you are doing is not good. So then try something else. You get it? So that's what we call reinforcement learning, where we are letting the machine learning model, we are letting the AI do a task, and then we tell it if it is doing well or it's not doing well, so that it changes the parameters that are involved in it doing that task. Now, for every machine learning, any machine learning thing that we are going to do, any machine learning model, any machine learning pipeline that you are going to do, there is a pipeline. All right. Sometimes when you are quickly doing tests and stuff, you are not going to go through all this pipeline. But at the end of the day, you are always going to be having this. We are going to go through these processes before you arrive at any finished machine learning product or any finished machine learning model. First of all, you have to get your data. Data is like the gold or the oil in machine learning. Without data, without good data, actually, without good data, there is no machine learning model that is going to be good. Data has to, data is your like your oil. So when we are going ahead and then we are trying to build models, you always have to make sure that the data that I'm getting is good, or I'm getting good data, reliable data. Because if you don't get reliable data, at the end of the day, your models are not going to be good. You are not going to be able to achieve what you wanted to achieve. So then we have the data ingestion where you are getting data. You can get data from scraping, where we go to websites and just retrieve information from the websites. We call that scraping. Or sometimes there are data sets. Like maybe you go to Ghana Statistical Service, there are data sets that are there, and then you download them. Or take health, for instance, you have your patient's information and all those things. Those things are all data that you have. Now, once you have gotten the data, you have to keep the data at a place where you can quickly retrieve the data. All these things we are doing, we are trying to first of all reduce what we call bottlenecks. Anything that is going to slow down the pipeline or slow down the whole process. And then you want to increase efficiency and speed. So you get your data, you make sure that you have stored the data somewhere that you are going to be able to easily retrieve that data. All right. So you get that data, and then it's not all data that comes in a right format. So let me use the health for instance. You've taken patient's information. Maybe in the writing, the person's height does not indicate the patient's height well or their age well. Maybe you see a height that is in like 300 meters or something. You know that okay, this is wrong, right? So then you have to prepare the data where we clean and transform the data to make sure that it is usable for what we are doing. And then you go to feature engineering, still on the health stuff. And we know that when you have a patient's height and weight and stuff. You can calculate things like BMI, and BMI is a very important index that you can use, to determine maybe a patient's health and stuff. So there are instances where sometimes the data as it has come, it does not contain a lot of information, but you can combine some information within that data to create more what we call features or columns or more data that will provide more information for you for the machine learning to learn. Why are we doing this? Because though data is important, data that contains information is also important. So you need data, and you need data that contains proper information that clearly distinguishes between different things, so that the machine learning models or the machine learning models and AI can learn from that. Once you have gotten all this, so you can see that in the whole machine learning process, there are like, let's say if you take these 7 steps, there are like 4 steps that we are doing to just work on data, right? Before then you don't come in just 1 step to train the model. So you know that you realize that training machine learning models is like your least problem. Okay, before I go on, I put this question in earlier. I want those who joined after to help us or to indicate. So I was asking that on a scale of 1 to 10, what's it's on a scale of 1 to 5, sorry, what's its individuals like? How will we rate our Python programming skills? So if you have joined here and then you haven't indicated that already, please indicate that so that we can just have a fair idea of the people that's or the skill sets of those that we have here. So yeah. Uh
Yeah, I think the question is very important because I'm planning on having a free crash course for them for Python so that when we get the numbers and we feel like they really need it, then we have that free extra crash course for them.
yeah. So we want to understand your skill set level in Python, because when we get to the more technical parts, if your Python skill set is not really you're not confident in it, aside from in the technical aspects, maybe it might be difficult for anyone to follow. So if let's indicate that so that we can use that information to determine if we have to do a quick Python crash course and get the majority of us up to speed. Because to work with the data, we need Python. All right. All right. So once we have trained the model and we have evaluated the model, evaluating the model is we are checking to see whether the model is giving us the results that we need. Right? The model is doing the work that we need. So let's say stuff like ChatGPT and stuff, the way to evaluate the model is that when you ask it a question, it is giving you the right answer. You don't ask it what is biology and then it is telling you something about photosynthesis, or you ask it what is biology, then to start answering photosynthesis is this one, then you know that, oh no, this model that we have built, no, it's not giving us the result that we want. So once you have gone through that process and then you have built the model, now all the work you have done will be cost 90 if you do not deploy the model. Deploying the model means posting it at a place where others can also use it. So OpenAI, when they spent billions and billions to build ChatGPT, what they did was what they hosted ChatGPT so that everybody in the world can interact with ChatGPT and use ChatGPT. So then they have gone through all this process, right? After evaluating the model, they've deployed the model so that me and you can use ChatGPT. And then as we are using ChatGPT, whatever issues pops up with ChatGPT, they are going to take up on those issues and use to build the model or improve upon the model. Now, we have talked about AI and then the concepts and everything that's going to be involved in it. Now, what are the career pathways that are involved in this AI and data aspects that we are talking about? The career aspects are like it's very diverse, depending on what you decide to focus on. We mentioned 4 different aspects here, right? In fact, all these 4 different aspects here, you can even have uh, let me say careers in them. So take data analyst. Data analyst takes the data All right. It doesn't necessarily have to store the data. You can just start building uh, graphs and dashboards and stuff to just explain the data. Yes, sometimes you would have to prepare the data in a way before he goes on, right? So then you have the data scientist who does what the data analyst does, but then goes on to also build models, right? So then you have data analyst, you have data scientist, you have an ML engineer who can do what the data analyst does and can do what the data scientist does, but goes a step further to build more in-tune pipelines and host the models and all those things. You get it? And then you have the data engineer who decides that, okay, me, I'm only going to focus on getting the data in uh, fast pipelines, in readable form, in accessible formats, in secure locations. You get it? Because, sometimes when we are working with this Excel data and stuff, they can be 2 kilobytes, 3 kilobytes. But then when you're in the real world, data can exceed 100 gigabytes, 200 gigabytes, 500 gigabytes. You get it? When you are at that level, no, now it is important how you are storing the data, how you are retrieving the data, how you are getting the data. Okay, health information, supply chain information. You can have very big database and table about uh, uh, tracks, routes, and all those things. And it becomes important how you keep the data so that when a data scientist is going inside it to go and access, retrieve that data, it's not like it's searching for pin in haystack, right? And then you have the AI engineer who can basically do all these four things that you have done. But then they focus more on building pipelines to host the models and all those things. Then you have the software developer. Now the software developer is just building software, right? But then nowadays you see that roles have software developer slash AI inside there because they are expecting that as a software developer, you are also able to build some AI apps or host some AI apps or even build your software to be able to interact with AI in a way. And then you have the cloud engineer that's sometimes interact with the data engineer to put their work out there. Now, how they all work together? Like I think I've mentioned that the data engineer gets the data, passes it to the data analyst. The data analyst derives insight, passes it to the data scientist. Then the data scientists build models on this data for business business use case. Okay, data analysts can generate insights from the data for business use case, but then sometimes data scientists have to build models to validate the insights that they've brought. Okay, to validate the insight that they've brought. Maybe you take a supermarket, the data analyst has built model that okay, in the supermarkets on Mondays and Tuesdays we have these type of people that are coming. So the data scientists will now pick the data from that supermarket and try to see if they can predict the number of people that are going to be coming on Mondays and Tuesdays and see if it aligns with the insights that the data analyst has generated. You get it? So um, that's how all of them interact. And then you have so yes, the whole loop you can categorize it in, let me say, 3 or 4 points, where you categorize the data point, where you have data engineers preparing data, scientists analyzing, and then engineers building the model, data scientists building the model, and then you have like the development phase, where sometimes these models you have to host them in a way that people can interact. Take ChatGPT for instance. It got at the beginning stage, it got to a point sometimes if you are interacting with the model to tell you there are too many people on interacting with ChatGPT, so come back later. That was because the infrastructure that had been built for ChatGPT, the people that were accessing ChatGPT had exceeded that infrastructure. So now they have to bring in more stuff and build more things. The ML engineers, the AI engineers have to build more pipelines so that when more people are coming, the ChatGPT can handle all that uh, query or all that request and still deliver to everybody without facing any issues. Then you have the development where the cloud engineers come in to make sure that whatever the ML engineers are doing, there's the infrastructure of the cloud can handle this. Then a feedback loop where all these people are consistently um, interacting with each other to be able to make sure that whatever they are bringing out is accurate and correct and it's not deceiving the general populace. Like I mentioned initially, some things that you have to understand is that we have so when I'm getting to the applications of AI, I want just like one or two people to just pick an industry that they fancy or like, and just talk about how uh, we can apply AI or ML there, right? So please let's just think about it. I need one or two people or even three people to just volunteer and do this for me. So when we get to the application of AI, just pick a random industry and just talk about how you can see AI being applied there. Most importantly, if you can use Ghana, it will be fantastic. Before we get there, what's an algorithm? I mentioned earlier, it's a set of rules for calculation of problem solving, basically a set of rules or logic that a computer will follow to reach a destination. That's the algorithm. And then you have a model, which is the model is like a representation of what the model of what the machine has learned. So everything that you teach the machine, we package it into one thing called something called a model. So it is that model that you carry around and then you use it for predicting. So ChatGPT like this it's a GPT model, right? It's a model that is there. It's sitting somewhere, and then when everybody and then there are like let me say different routes for people to interact with it. And then you do that. Training the training process is when we teach the machine learning model using data. Sometimes yes, using data, either labeled data or unlabeled data. And then inference aspect is when you are using that model to predict on new data. Okay, you are making predictions using that model that we have trained on new data. Now, data set is basically like a collection of data that we are going to be using for the machine learning models. So now, a question that I'm throwing out to my students or the students over here: what industry in Ghana do you think, okay, it's not really seeing AI much? Even if it's seeing AI much, what's, yeah, yes, industry in Ghana, uh, do you see we can apply AI? And then how do you think we can apply the AI in that? Any volunteers? I've spoken a lot, so now I want to just push it out there. Yes,
So good evening to everyone.
yes, good evening.
I go by the name Richmond Mensah.
All right,
I think I joined late though, but I've learned a lot.
okay,
Okay, so to me, in Ghana, the agricultural sector is
okay,
lacking AI a bit though, but I think AI can help in also in crop monitoring. When I say
all
crop monitoring,
right, all right.
when I say crop monitoring, maybe we're able to detect pests and then other diseases. Also, maybe AI will help in analyzing the soil health. I think other countries have started with it, maybe not more advanced, but I think we should also start with it.
All right. You said your name was Richmond, right?
Richmond Mensa.
Richmond Mensa. Okay. Fantastic. Fantastic from Richmond. So Richmond says the agricultural sector we can apply AI in soil health monitoring, right? And then pest detection, if I can put it that way.
Yes, please.
All right, all right. I think that's a fantastic example. And the agricultural sector is actually a very big sector in Ghana here, so that's very good. Yes, anybody else aside from Richmond? Yes, anybody else? Oh, I should mention him. Should I randomly sample a person? Okay, let me pick an industry. Security. Security. How do you guys think that we can apply AI in security? Hello. Please let's mute ourselves and hey, let's unmute ourselves and just one person. I just need one person to help me here and then we can move on. Security, anybody?
Yeah, so that's Francis.
Yes, I.
And now when he said security, I was laughing a bit because I was wondering how AI can help us detect thieves and then deploy solutions how to prevent them. Yeah,
Yeah.
I'm just thinking aloud in that area.
Okay.
Yeah.
Yeah, that's actually quite fantastic. All right. So I think in the first world they have no they have security cameras everywhere. And then one thing they do is there's something we call intent monitoring or intent detection, where they try to determine the intent of a person, of any individual, or all the people that are working. Sometimes it's the train station or anything. They just try to determine the intent in such a manner that is the person's intent to the far negative or to the far positive. Usually they don't care about the far positive because then those people are not risk people, but usually to the far negative. Usually they do this because of they have a lot of terrorists and all those things. So um, that's even when you are looking at it from the security camera aspect. But then also you ask yourself that how do uh, um, countries like how do institutions like the FBI and then the is it the NC or the NIA forgotten, how are they able to, let me say, detect terrorist attacks ahead of time? These are, let me say, these bad people, they use coded language when they are communicating, but they have models that are there to try and decrypt all this coded language and stuff. And then at the end of the day, if you're able to determine these attacks or determine all these plots that they are plotting ahead of time, it's a matter of national security, right? It's a matter of security, and you're able to determine it ahead of time. All right. So, um, uh, so then we have healthcare, right? We have in healthcare. When COVID came, right? When COVID, after COVID started coming, a lot of data sets came out where we try to determine um, pneumonia and or COVID or lung issues using an X-ray scan of a person. Because there were a lot of people that contracted COVID and there were a lot of scans. Now those data sets came out, so now people can build, let me say, COVID detection apps. And you also have this app here that is detecting birth aphasia in Nigeria. And then you have fraud in finance. In finance, there are a lot of people out there to, fraud people. So they have a lot of all these models that are there to determine fraud, and most importantly, risk assessment, right? To determine the risk of certain trades or certain people that are coming for loans. If your risk is low or if your risk is high, so these models, they put together all the data about the person, social media data, your credit data, your bank data, your all these things. They put all those data down, and then there are algorithms down there together with the models that are sort of able to assess a person's risk. And most importantly, in retail, you go to Amazon store, you are buying a product, and then they'll be like, okay, people that buy this product usually buy this product in addition or recommended products and all those things. All those things are AI models that are in the background trying to get consumers to not just purchase what they've come to buy, but purchase more. So the more you are able to get consumers to purchase more, the more money you are making, right? And then in automotive, now this me a personal industry that I like, that's self-driving cars. You have companies like Waymo and Zoox and Cruise that are all building, or even Lyft, that are all building self-driving cars, such that in the near future, they call them level 5 driving cars or level 4, level 5 driving cars, so that in the near future, um, we are able to reduce accidents because of human error and all those things. And then and I think Tesla has even started something that you can have your own self-driving cars. When you are not working or anything, the cars will go and go and do, let me say, ride sharing for you. So you have your self-driving car, and then the car goes and works for you, and then you get some money. I mean, that's a fantastic use of AI, right? Then you have agriculture, like our brother said, and then energy or in the energy department. Now, what you are going to be seeing as used mostly, the programming language that you are going to be seeing as using mostly is Python, right? Python, we are going to be using Python from the very beginning. Why is Python? Because Python is widely used, Python is widely maintained, Python is widely documented. You find so many tutorials on Python. If you have any issues, you can easily find a solution with Python. There are programming languages that do that as well. And then Python is also easily readable. So then you don't have any, it's very easy to understand Python text. And we are going to be, for testing and for quick development, we are going to be working in what we call Jupyter notebooks. Okay. So in our next meeting, I think Saturday or anything, we are going to go into this environment and just get hands on, right? So you have Jupyter notebook, you have Google Colab. Google Colab is basically Jupyter notebook, but in the cloud, so that you don't have to have the resources on your machine. When you're using Jupyter Notebook, it uses your machine's resources. So if you don't have a strong machine when you're running certain things, it will take long. But if you are using Google Colab, it uses Google's resources. So then if that you are running with something heavy, it's not take long. You have scikit-learn, which is like, I think it's called Science Kits or something, but it basically has all the scientific stuff. And then you have SciPy, which has the more of the statistical and other stuff. And you have TensorFlow, that is the deep learning framework in Python. And then you have Keras, which is a smaller version of TensorFlow. Yeah, there is PyTorch, there is NumPy, Pandas, and all those things. You are going to have to basically have a fair idea of most of these things before we go on. So as I'm getting, I think this we've gotten to the end of it. One thing that's very important, all right, as we are going to be teaching here, is that you find some book and and read. Now there is this book, Introduction to Statistical Learning with Applications in R. Now, data science, right? Many people don't mention this. Though we are going to be doing the technical aspects, right? But data science, to some degree, is highly dependent on the statistical aspect. Take, for instance, you are doing a regression problem. A regression problem is we are trying to predict a continuous value. Now, what's a continuous value? Take house prices. You want to be able to predict how much any house that you take in any area is going to cost, right? House prices are not fixed values, right? They are they are they are not fixed values. You want to predict those things. Regression problems, which is based on the equation of a line, like this. It has some statistical background to it. All right, you have some statistical things in the background that will help you understand the models that you are building and help you understand what is wrong with your models, so that you can find if you have to get more data, if you have to tune the model, like this is the statistical part that helps you understand. So you have this book, Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. And then this is to help with the machine learning aspect. Though it's also going to be talking about the data science aspect and all that. But then you also have introduction to statistical learning with R, which was one thing that I also started doing at the beginning of my career, and it's going to be very important in your journey if you really want to understand career. Now, for those that, if you really want to understand data science, for those who want to build themselves more in the analytics aspects and then storytelling with data and all those things. So you can just say it on the page. There are other books like data storytelling and all those things that will really help you in that aspect. But aside that, please, if you have any questions, let me hear it. Let's have your questions, and then we can look forward to the next mission. Yes, go for it. I think you've raised your hand.
Yes, someone please can you put on the page the list of materials you recommend that we read?
You read, all right. I'll put now if I put too much there, it becomes a little bit daunting because this book like this, it has so many pages. It is like 441 pages or something. So yeah, I'll put maybe one or two materials inside there that you should just focus on. And I'll do so. Yes, any further questions?
Hello, Samuel. Mr. Samuel.
Yeah.
Thanks for in fact the insightful lectures. I want to know. I have a zero knowledge when it comes to the Python. I want to learn. I want to learn. So, is it a good starter for me? Is there any way I can improve myself? Any material in that area in terms of the Python?
Yeah. So some let me come in here. I think
Okay.
so. We are planning a crash course for you guys. Okay. So we'll give you the start date soon. So at least something to get you started. Then later on you can build the rest on your own. Yeah.
Okay. Thank you.
Okay. So once that crash course comes, there are some material that I can forward in. You see, sometimes the reason why we don't want to put so many materials in at the go is when it becomes plenty on your palette, then you do a bit of this, you do a bit of this, you do a bit of this. But what we are trying to do here at Get Skills is trying to let everything be focused, everything be streamlined, everything be one by one, right? So once Shadrach sets up the Python crash course, from there, then we'll put extra materials that you can use to improve as we go ahead with the uh, data science course. Yes, anybody else? I think we have exhausted our time. So, anybody else? Any questions? Yeah, so the next session is going to be on Saturday, which is going to be a more hands-on session. This Wednesday sessions are going to be more theoretical since we are only spending a day, an hour inside. But depending on how the theory is, we might have to put some practical and technical aspects inside. So it's going to be Wednesdays, Saturdays, Wednesdays, Saturdays. Okay. Wednesdays for more background into what we are coming to do, and then Saturday for more in-depth hands-on. So after the Saturday, when we do the hands-on, then there are going to be some exercises at the bottom that you are supposed to do that we'll discuss the next Wednesday. All right. So if you don't have any questions, I want okay, Godfrey.
Yeah, so I want to ask, by Friday, should we have already downloaded the Jupyter, or we'll go through how to download it on Friday? I mean on Saturday.
Okay, if you can, why not? You can do that. But when we come Saturday, from the beginning, we will take you through getting the Jupyter set up, getting an environment set up to be able to work.
Okay, thank you.
You're welcome. All right. So then, this is a question that I'm going to throw to all of us. All right. From all the things that I've talked about today, from today's session, okay, what's one thing that's you are excited to try yourself, or are excited to learn more about, even if not in this session, like on your own? One thing that's after this session you're like, nah, listen, I have to find out more on my own. I have to learn more about it. I This is a question that I'm putting. I mean, I want to understand the students that we are here more. The more I understand the students that we are here, the more we are able to tailor, tests and all those things to we the students that are here. So please, the floor is yours.
Okay, someone.
Yeah.
Yeah, so I mean, for me, this introductory course has been an eye opener. I mean, knowing that AI and machine learning involves a lot, there's something called pipelines and training models and how to build models. So I'm looking to be able to learn all the things. If the
Oh,
time comes, we can learn all these things. So, yes, please.
oh,
Thank you.
all right, thank you. I did not hear the last part of what you were saying because your this one became muffled. But I guess you were talking about pipelines and then
Yeah, yeah. So, let me know.
yeah, I can hear you.
Yeah, I was saying that today has been an eye opener because I've learned a lot about AI, machine learning.
Yeah.
I mean, about there's something called pipeline, and there's some I'm learning out that there's something called building models and training it, and I'm hoping to be able to learn it. And if I'm able to master it, I'll be able to try it on my own too. Thank
Ah,
you.
that's thank you, thank you. You see, sometimes we don't even have to think about this in even industry level. Sometimes you have something that you are working on. You can see that oh, there is a lot of data that is going on. Sometimes you have to be doing things repetitively. Then you be like, ah, me I have Python, this Python skills and all that. So then you write a Python code to just do that thing for you, and then you have solved the problem. So at the end of this program or at the end of the statistics. Don't worry, the statistics is a very if you are lucky and then the line of work that you enter into, you don't have to use the statistics more, you thank your God. But when but data science actually goes with statistics a lot. It doesn't go with the maths aspect a lot, it goes with the statistics part a lot. When you're in ML and then you have to be in the application aspect, now that depends on the statistics, the maths part a lot. Take ChatGPT for instance. The, there was a math. There's a lot of maths that's in the background. When you go back and then you go and read the the article or the published report about it. So yeah, I hope you have whet your appetite for data science or ML or AI. We hope that you are going to continue joining with us. You are going to be learning on your own. You are going to come to the meetings or the classes with so many questions and with more curiosity so that if there are things that other students are there and they do not understand from the questions alone or from the questions that we are answering alone or we are discussing, we can all come to a total understanding of everything that we are learning here. I guess we can call it a day then. Thank you all for joining today's this week one of the data science course. Uh, please do make sure that we'll share the recording. We'll send the recordings inside. You can listen to it again. Do make sure that you are finding resources on your own to learn. We are going to be linking you to YouTubers, to resources. It's all about learning, 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 learning. And then at the end of the 3 months, make sure that you are able to build a product. All right. God bless you all. Have a good night. Bye bye.
Thank you very much.
Yeah.